Hello everyone, welcome to the show. How are you doing today? Today we are going to talk about matter in our surroundings. As we look at our surroundings, we see a large variety of things with different shape, size, and texture. Everything in this universe is made up of material which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, plants, and animals. Even a small drop of water or a particle of sand, everything is matter. Since early time, human beings have been trying to understand the surroundings. Early Indian philosophers classified the matter in the form of five basic elements: air, earth, fire, sky, and water. According to them, everything, living or non living, was made up of these five basic elements. Ancient Greek philosophers had arrived at a similar classification of matter. Modern days, scientists have developed two types of classifications of matter based on their physical properties and chemical nature. In this episode, we will learn about the matter based on its physical properties. Chemical aspects of matter will be taken up in subsequent episodes. Physical nature of matter. In order to get inside the matter, we need to be clear about what is the matter made up of. This question was unsatisfied for a long time. In ancient time, there were two schools of thought about matter. One school believed that matter is continuous like a wooden block. Other said matter is made up of particles like grains of sand. Unfortunately, both schools had only their theoretical explanation, but none of them come up with any practical demonstration. In around 450 BC, the Greek philosopher Democritus introduced the idea of atom. However, this idea was essentially forgotten for more than 2000 years. But in 1800, John Dalton found that matter is made up of particles and reintroduced the atom with practical evidence. When it was confirmed that matter is made up of particles, scientists started to study the characteristics of particles. They are as given below. 1. Particles have space between them. For better understanding, let's take an example. Take a biscuit and a cup of tea. Dip the biscuit in tea. You will see that tea is soaked by the biscuit. In other words, particles of tea are stuck in between the particles of biscuit. So, how this is possible? This phenomena could be only possible if particles of biscuit are big with empty spaces between them, and particles of tea are so small that can be fit in that small gap. This conclusion proposed that particles of different matter are different in size, as particles of biscuits are larger than the particle of tea. Hence, particles of tea found a space in between them and got stuck there. 2. Particles of matter are continuously in motion. To get this point, let's have an observation. Take a beaker about 500 ml, fill it with water, and put a small spoon of color in it. You will see color is moving in the water. Observe it after some time. You will see color is integrated into particles and yet moving continuously. Observe it after 1 hour, 4 hours, 8 hours, 1 day, 2 days, or 4 days. Still, you will find that particles are moving in slow motion in the beaker. Hence, it is known that particles of matter are continuously in motion. The energy particles possess while motion is known as kinetic energy. As we increase the temperature, the kinetic energy will increase and hence the particles will start moving with more velocity. 3. Particles of matter attract each other. Let's take iron nail and chalk. Try, try to break iron nail with your hand and then chalk. You will see that breaking an iron nail with hand is not possible, while you can break the chalk by applying some amount of force with your hand. Now put your hand in between the stream of falling water from an open tap. In this case, you don't even need to apply any force, as you will place your hand in between the falling stream and you can break the structure. So, how these matters show different behavior? This behavior is due to the fact that the particles every the particles of every matter are holding each other with some forces. This force is known as force of attraction. More the force of attraction, more will be the matter stronger. This explanation also suggests that force of attraction varies from material to material. So, in case of iron nail, force of attraction are very strong. They are strong enough that you can even break them with your hand. And in compared to nail, the force of attraction in chalk are quite less than the force of attraction in iron. So that's why you can break the chalk with your hand. And the force of attraction of water are very low, that you don't even need to apply any force in order to change the structure or break the chain. State of matter. Based on these three basic physical characteristics of particles, matter are classified as solid state, liquid state, and gaseous state. So, solid state. Let's take a pen, book, needle, and a piece of wooden stick and try to change their shape by hammering, pulling, dropping, or compressing. We can observe that it is nearly impossible to compress the solid. This is because solids have negligible space in between their particles, hence its compressibility is negligible. That's why their particles have very low kinetic energy or low tendency to movement. Hence, solids have definite shape and distinct boundaries. We also observe that solid is rigid. Breaking them needs a large amount of external force. This is due to the fact that particles of solid hold each other very tightly, or solids have very high interparticular forces. Liquid state of matter. Let's take water, cooking oil, cold drink, or milk. Observe them by splitting on the ground, diffusing with other matters, and keeping in other container. Let's pour water on the ground. What will happen? Unlike book or pen, water will split all over the ground. This behavior of water is because liquid has no fixed boundaries, neither any distinct shape. Hence, they split up freely on the surface. Now, let's try to diffuse other matter with liquid. We can observe that liquids and solids and liquids diffuses like sugar and water. Similarly, liquids diffuses in each other very rapidly like water and milk, and gases diffuses in liquid more rapidly like oxygen in water. This is because liquids have more space between their particles as compared to solids, or we can say that liquid have low interparticular forces. We can also observe that rate of diffusion of liquid in liquid is greater than the rate of diffusion of solid in liquid. This is due to the fact that in liquid state, particles move freely and have great space between each other as compared to the particles in solid state. Let's observe that liquid while keeping in different container. We can observe that there is different shape of liquid in different container. It takes the shape of container but its volume remains same in every container. This is because the liquid have no fixed shape but have a fixed volume. They take the shape of container in which they are stored. Liquid flow easily and changes its shape, so there is no rigid. So they are not rigid, but they can be called fluid. Gaseous state. Let's take 3 syringes and close their nodes. Now put water in first syringe, chalk in second, and keep third syringe empty. Now try to press the piston with your hand. In this activity, you can observe that chalk is negligible compressed, water is considerable compressed, and air is highly compressed. This compressibility of gas is because it has very high interparticular spaces. Hence, large amount of gases can be compressed in a small volume of liquid and transported easily. We have observed that when a scent stick is lighted in a corner of room, just in few seconds, its smell spreads in entire room. While when it is kept unlighted, we need to get very close to smell them. This is because gas have very high tendency to move freely, or it has very high kinetic energy. Hence, particles of gases occupy the container in which they are kept and exert pressure on the wall of container by striking them continuously. So we can say that gases don't have any fixed volume. If LPG gas in kitchen is kept open, all the gases will escape in the atmosphere. This is due to the fact that gases have very low interparticular forces of attraction and very high kinetic energy. Solid have very low interparticle space, solid have very low kinetic energy, and solid have very high interparticle forces, while liquid have very moderate interparticle space, moderate kinetic energy, and moderate interparticle forces. And gases has very high interparticle space, very high kinetic energy, and very low interparticular forces. And we can also group the other features like solid have fixed volume, solid have a definite shape, solid have very low compressibility and very low randomness, while liquid have fixed volume but liquid don't have any definite shape, but liquid have moderate compressibility and liquid have moderate randomness. And gases, they don't have fixed volume, gases don't have fixed shape, they have very high compressibility and very high randomness. So we learned about physical nature of matter. Now it's time to go, but we will see you soon. Until then, think about this: when liquid diffuses in each other so quickly, why oil floats on the surface of water instead of diffusing? Let me know in the comment box. For more information about this or any episode of this series, check out the blog. Link is in the description. We have additional content for the readings and transcript of every show. If you value the show and educational resources and want to help keep it going, subscribe the channel and also subscribe the blog, or alternatively you can like, comment and share the show. It may be just a click for you, but every little bit adds up. Thank you for coming to the channel and watching the video. I hope you love the show. Thank you.